after we discussed a lot about quadratic relations, let's go further to what's in this material. So the second line is the general form of quadratic relations that we will discuss this chapter. Ax squared plus by squared plus cx plus dy plus e equals 0. As you notice that there is a b, c, d, e. So they are not variables. Okay, just keep in mind a, b, c, d, e are not variables. They are coefficient of each term, the numbers of each terms. So later on, we will replace them with any numbers. There is restrictions of numbers that we have to use, but just keep in mind that the variables only the x and y. Okay, so let's discuss whether this relation contains quadratic polynomials. The first term, ax squared, it means it contains only two variables. Why? Because x squared represents x times x. There are 2x. The second term is also two variables. There are 2y. And the third term is only one variable. The fourth term is only one variable. And the last term there, we don't have any variables. Equals 0. So it doesn't matter if a polynomial contains terms which have variables less than 2, as long as at least one of the terms contains two variables. So we have quadratic polynomials. If this is the case, if we change the a, b, c, d, e with any numbers, later on, if this is the general form of your quadratic relations, usually these relations, not a function, these relations can shape into a circle, ellipse, hyperbola, or parabola. These four shapes are the shapes that we are going to discuss this chapter. Okay, now in this subchapter, we will discuss more about quadratic relations that when you graph it, it will shape into a circle. That's what we discuss for this subchapter. So for a circle, okay, we have two skills that we aim you to master. So these two skills are, the first one, when you are given an equation, whether it is a general form of quadratic relations or a general form of circle, when you are given an equation, you can figure it out how or what is the radius of your circle, where is the center of your circle, and how to graph it. Once you have the center and once you have the radius, actually it's very simple to graph a circle as long as you have a compass. And the second skill that we will discuss is when you are given a circle or when you are given a center of a circle and a coordinate that it contains, you need to figure it out what is the equation. Okay, so we will discuss these two big skills that I want you to master. So I will separate these videos into two other parts, this one and the second one. This part will discuss the first one, the first skill. Okay, so let's start with the general form of a circle. So before we go to the circle, let's go to the general form of a quadratic relation first that we will use on this chapter, which is the thing that I have already written on my whiteboard before. But let me just write it again on this paper. Cx plus dy plus e equals 0. Okay, so a, b, c, d, e, again, it represents numbers, not variables. So the variables only x and y, and this is quadratic. So the general form of your circle will be x minus, let's use h, square plus y minus k square equals r square. Okay, so where the center, the coordinate of your center will be h comma k, and the r is the radius of your circle. Okay, so for example, if I have, let's go to the general form of a circle first. If I have x minus 3 square plus y plus 5 square equals, for example, 36. It means 36. It means the center coordinates will be 3, negative 5. See, this is negative, this is subtraction. Since this is also subtraction, so just take the age as 3. And for the k, because since this is not subtraction, this is addition, this is subtraction, so it will be the opposite of the number here. It will be negative 5. So the center is 3, negative 5. How about the radius? The radius will be the r square. So it's not 36. Since 36 is 6 square, it means the radius of your circle is 6. So this equation is a circle with center 3, negative 5 and radius is 6. For graphing, later I will show it to you. So this will be simple if you can have this general form of a circle. But the thing is, when you are given a quadratic relation general form such as x squared plus y squared plus, for example, 2x plus, not 2x, it's 4x plus 6y minus 36 equals 0. Okay, so first, of course, you don't know what kind of shape this is, but I will tell you that this is circle. So I will write down again the general form of quadratic relation. dy plus e equals 0. Okay, so let's compare. So the a for this equation is 1, the b is 1, c 4. Okay, let me just make it 4 really. Sorry. And d is 6, e is negative 36. Okay. Okay, so we replace all of the a, b, c, d, e with numbers. So that is the meaning of a, b, c, d, e, not variables. Now, it is a circle. Why? Because a circle, the a equals b equals 1. Yeah, so that is the first hint for you. When you can simplify a quadratic relation and you find that the a and b equals 1, you can get the feeling that this will be a circle. Of course, it will be a problem if you are given this equation which you cannot extract directly. What is the center of your circle? What is the radius of your circle? Right? It's different with this general form of circle when you can extract directly the 3, negative 5, and 6. So how do you get that information from this kind of equation? So you need to convert first this form into the general form of your circle. Okay, so this is the hard work for us. So let's convert this into the general form of circle, which let me just rewrite it again. It is x minus h squared plus y minus k squared equals r squared. So keep in mind that at the original general form of your quadratic relation, the right member only has 0. So you need to put a number here. A number. There is no variable here. So that is the first clue. So let's just let's just move this one into the right member by adding both sides by 36. So then the first thing that you need to do is adding both sides, and I do the commutativity for addition like this. So from here, the origin, into this. I hope this is clear. Okay, I add both sides by 36 and I switch the side, which is using the commutativity for additions property or axiom, and then I will make this one and this one into a perfect square so it can comes into this form. So okay, let's just do that. Okay, so I will add this by 4. So originally there is no 4, but I will add it by 4. And then I continue with the y. I will add it by 9. So because I add something on the left side, I have to do the same with the right member. So I will add it by 4 and I will add it by 9. Okay, what is the purpose? Let's just continue and then you get the idea. So this is a perfect square. So it is x plus 2 square plus y plus 3 square equals 49. So look at this. Compare. We have now the general form of your circle. Let me just make it more completely the same. So it is 7 square. So from here, now I can know that I can extract directly the information that the center of this circle is -2, -3, and the radius of the circle is 7. And then I will graph it. So yeah, here's the way that you need to know.